This is my second video class of the second chapter, Force and Laws of Motion. Okay, today I am going to explain the famous Newton's laws of motions. So before which the famous scientist Sir Isaac Newton established in 1686 the three famous laws of motions. So before explaining the laws of motions, let me explain the history behind the three laws of motions. Before Sir Isaac Newton established these three laws of motions, so based on which idea I am going to explain today. First of all, Aristotle, a famous scientist, he used to think that if a moving object, when moved, to continue its motions always require an external force to continue its motion. Suppose a body is moving in a straight line, so to continue its motion, it requires some external force. Why he told like that? Because when a ball, if I roll a ball on the ground, then the ball, after going some times, it will stop. So that Aristotle used to think that why this ball stop? If I want to continue its motion, the ball's motion, then I have to apply some force externally. That is the conceptions of the famous scientist Aristotle. But Galileo, that is his wrong conception, which was rectified by another famous scientist, that is Galileo. Galileo thought that to rectify his conceptions of Aristotle, Galileo did some experiment. What experiment he did? Experiment number 1. This is experiment number 1 and experiment number 2. So what he has taken, Galileo taken to the inclined plane. This is inclined plane. So when he drop a ball, that its speed is increasing downwards. When it threw the ball upwards, he found that the speed of the ball decreasing upwards. And this was his first experiment. He understood that ultimately the ball's velocity or speed is decreasing upwards, but there must be something which stops the speed of the moving object. Now again he did the second experiment. Here he has taken hemispherical container where he dropped one ball. Then what he found, that when he dropped the ball is going from here downwards, again it's reaching up to here, and again it's coming back and going up to here, the same distance. From which distance is coming here, it reaching up to here, again it is coming here and going. In this way, it just oscillating. Secondly, he took a big container hemisphere where he just increased the distance of this one, and here he dropped the ball, and the balls, see, from here to here, it covering a larger distance, but still it is going to the same distance as it is beforehand. Same distance it is reaching up to here to there, and this way. Now last one he has taken, he done one side of this container, he just made flattened, and what he found, he dropped the ball and is seeing the ball is going continuously in the same speed. After some time the ball comes to stop. Then from his experiment, Galileo came to the point that there must be something which stops the ball. When the ball is going here and it's coming down, it stops its velocity, speed here going, stops its speed. So after going horizontal plane also, after some times, the ball comes to rest. So he thought there must be something which makes the moving object to rest. Then what is this? Then he found that this is nothing, this is the frictional force. Frictional force were in the touching the surface, both the surface of the ball and the surface of the container, where the frictional force arises, and this frictional force always opposes. That means if ball is moving this side, the frictional force is acting this side, means is always just pulling the ball towards opposite side, which ultimately makes the balls to stop. Then Galileo told that if we can remove the frictional force, so then the object which is in moving conditions cannot stop. It will continue its speed forever and ever. This is the Galileo's conceptions and rectifications, whatever you can see. And Aristotle's wrong conceptions was also known as Aristotle fallacy, and his Galileo's ideas, which he, after explaining what he got, that is Galileo's remedy. So based on Galileo's remedy, Galileo's experiment, the famous scientist Isaac Newton in 1686 is established three famous laws of motion. Three famous laws of motion. What he told, that if we don't want to change the state of an object, I'm explaining afterwards nicely. So, let me state what the first law is of Newton is telling, that if an object, if I don't change the state of an object, that object continues its state, whether it is in rest positions or it is in the moving conditions. So this one we have to explain. Suppose I am keeping a box. In the school you have seen the chair, bench, tables, whatever, if you keep this, so unless you change or make them to change their place, they will be in this same place forever and ever. Unless you just push or pull it, the tables, chairs, so that means they continue their rest positions. Similarly, if according to Newton's told, if I roll a ball, so according to Newton's law, then ball should keep on its moving conditions forever and ever, but ultimately we are not seeing. You can say, ma'am, after some time, so it will come stop in rest positions. So that explanation is also there. So what happened? But according to the first law of motions of the Newton's, what Newton's told, that the moving object will continue its motions forever and ever. So until and unless we change, we apply any external force to change its state. Now the questions arising, that if you ask a man, okay, rest positions, I don't have any problem, it will be in rest positions. But what about the moving objects? It won't continue. It will stop after some time. Why it will stop? We are not touching, nothing we are doing, but still it is stopping. So the answer is there, that there is a friction between the moving object and the surface on which it is rolling or on which it is moving. So the frictional force in between the surface of the moving object and on which the moving object is rolling on. So the frictional force is opposing, pulling backward, and it's making the object not to move, just pulling backwards and opposing the portion of the object. That's why after some time the moving object comes to rest. So now Newton's first law of motion is also known Galileo's laws of inertia. Galileo's laws of inertia. So what is inertia? Inertia is the enhanced property of the object. That means better to say that own property. Suppose if I more clearly say that, suppose each and every public you have your own wish, own idea, own conceptions. So if I want to convince you, if I want to move you, then I have to apply something to, because suppose I am calling to come with me, some student come with me, then he does not want, then what? That is his in a property, not to come with me. So same thing, object which is in motion, this object has the property to continue its motion. That is its inner property, that it wants to continue its motion. Same thing, object is at rest, its property also to continue its rest position. Okay, so this, so what is inertia? Inertia is the property. Inertia, better to say the inertia is the inherent property. This means inside the objects, one property, one quality, which tends the object not to change its state. Suppose rest positions, its inertia means its property or its whatever quality, whatever you can say or wish, that I won't change my rest position. Same thing, the moving object, its inherent property to, if I want to stop it, but it property or this one, whatever quality you can say, that it always try to oppose. No, moving object will say no, I won't stop, and rest object will say no, I won't move. So this inherent property which tends to opposes its state, to change the state, means I want to change the state, but the object is wanting not to change. This inherent property is called inertia. So inertia, now what, there are two types of inertia. One is inertia of rest and inertia of motion. What is inertia of rest? That due to inertia of rest, if your body is in rest positions, so if I want to move it, I apply some force. Okay, so to oppose, why I have to apply the force? Because the property, inherent property which I am telling inertia, the inertia which opposes not to change the state, means I am in rest, I don't want to change my rest positions. But if someone telling me, wanting or wishing to make me to in motion, then what? They will push me or pull me. But I have a wish and not to move from here. So then with my strength I oppose. So this my strength which is coming from inner side, that force you can say it's my inertia. Okay. So inertia of rest, because I am standing in rest positions, I won't move. Okay, but somebody is wanting to push me or pull me. So they have to apply some force. This force, why? To overcome my inertia, means my opposing force, not to move. My opposing force, what is telling? I won't move, I will stay here. But the person who is those who want to pull me or push me, they have to apply what? To overcome my inertia, my inner state, my inner force which opposes their force. So if their force is more, then I have to move. If their force cannot overcome my force, my inner force that I know, suppose a small kid came and comes and try to push me. So my inertia is no, I won't move. The small kid cannot, because his force cannot push me, because my inertia, my opposing force is much more greater than the kid's strength. But if a strong person comes and he push or pull me, so my opposing force easily can be overcome by that person, by the strong person. So I have to move. Same thing happens. happen with the object. If I take a big object, suppose I am doing here. Now, if I take a small box, small empty box, okay, empty box, so what, anybody can push it this side or anybody can pull it this side or this side can easily can push. Because why they can do? Because this box is empty. Now if I take a big and solid box, heavy solid box, then the persons who easily can push this box, that person cannot, heavy box, that person cannot push this box or pull this box that much easily, or cannot push as he or she can here. So what is this? What the things happen means the inertia. What's the difference came? Here the empty box, here the heavy solid box. So the difference came due to the mass. So what is the relations between the mass and the inertia? Inertia means opposing force. More I am strong, more my opposing forces will be there. If I am weak, then my opposing force also will be weak. Same thing. So what come to the conclusions? There is the relations between the mass and the measure of inertia. What is mass and measure of inertia? If the object is heavy, then the inertia means opposing force. What is opposing force? Not to change my state. I am in rest to rest. I am in motion, I want to continue my motions. So if the mass will increase, then the opposing forces, that means opposing force also increase, means you cannot change their state. That means if the box is in a rest position, you cannot change the box, heavy box, that much easily, as much easily you can change the empty box, its positions. Okay, so what came to the conclusions? That the object with more mass have more inertia, and objects which have less mass which are having less inertia. Now many examples I am giving you. Suppose in the swing. So if I in the swing, normally you see swing, that means if a small kid, I easily can make the boy or girl can make them swing. But in place of small kid, if I make a heavier person, is it possible for me to swing the person easily as I have done before and while I swinging the kid? No. Why? Because the man is heavier, much more heavier than the little kid. To that time, that means his rest positions, his opposing force is much more than my strength. My applying force tending or trying to change its states means rest to motion, but his inertia or his opposing force tending or opposing my force not to change. So as the mass will increase, the inertia also increase. Same thing happen if I take a toy car in motions, I can easily stop the toy car by my hand. But if a vehicle, four-wheeler, two-wheeler, with the speed they are coming, is it possible for me to stop it by my hand? No, I will be injured, there will be accident. Why? Same thing. Because the heavy vehicles, they have more inertia not to change its motion condition. Because the vehicles which is in speed, it is tending, it is when I want to stop it, but it's more forces, opposing force, which is called inertia of motion, that one does not want to change its motion condition. So that means heavier object have more inertia and lighter object has the less inertia. Okay, so due to the inertia of rest, now when a body will be in motion, so a body will be in motion. So I already explained the unbalanced force. When the applied force will overcome the inertia of rest, that means opposing force of rest, that this body will be in motion. Again, if a body is moving in a constant speed, to that body, the force which acting on the body is a balanced force. Why balanced force? Means that there is no increasing of speed. If there is no balanced force, I already explained in previous video the balanced force, what is balanced force. So if there is no balanced force is there, if some unbalanced, that means if any force is more, then what? The speed of the object will increase. Now here the Newton's given some experiments. That is, first one is coin card experiment. Coin card experiments you can do at home. You take a coin and take a postcard and keep a coin here and take a glass of water. Suppose in this way, a glass of water, and put a card and put a coin. Now if you just strike the cards very fast, you have to do very fast, then what will happen? The card will move away but the coin will fall here. Why it will happen here? Why these types of incidents happen? Because then if I strike the cards will be in motion. Okay, before and cards and the coin both are in rest position. So if I strike the card, then what will happen? The card will be in motion, the card will move away. But due to the coin still is in rest positions, and as I don't apply force on the coin, the coins, they eat inertia of rest, insist the coin to continue its rest position, and due to its rest position it will fall here inside the glass. Another striker in the carom boards, perhaps you know better than me that you students, you play carom boards. In a carom boards, what happened here? So the coins we are keeping in the middle like that only, and by a striker, if I hit the lower one very first, I am telling very first, don't take too much time. Very first, if you strike, so there is a game. Who can do this one so many times? There's a points also. So if you strike by a striker, the last one, so you will see the last coins of the carom board. This one will move away here, but what the rest, this one will stay as it is. Why? Because due to the rest, when I apply force by the striker to the lower one, the lower coin is in motion and this one will move away, but the other, we are not applying force, the other one, so other coins, so they will keep their rest positions, rest of inertia of rest. Due to the inertia of rest, these all coins will stay as it is. This is another. Now remember, experiment on Newton's first one, daily life. What is daily life? Or let me do 1 and 2, let me explain. After the next video I will explain. Let one only I will explain today. Now when a bus starts, suddenly the passengers fall backwards. It is very common experience to all of you. Whenever we are going by bus anywhere, so all of a sudden, suppose the bus driver just gives the brake, applies the brake, and we just, what happened? Sometimes we move forward. We move forward. So why we move forward? Because and sometimes if I'm not cautious, we can get hurt on the front seat also. So why it happens? It happens because same. When this is the experiment, this is the example of movement, inertia of motion. See, when we are going by bus, that time our lower portions which we are sitting, that is also motions, full body is in our motions. So when the driver applies the brake, then what will happen? Our lower portions which just touching on the seats, that means with the touching in the bus, so that then and there it just stop. The lower portions stop, but upper portions they continue the motion, inertia of motion. Due to inertia of motion means continue the motion state. Upper portion still wants to continue the motion state, so that's why upper portions will move forward. Same things happen if we are sitting in the bus in the rest positions and we are sitting nicely. Suppose we are talking, gossiping, but all of a sudden the bus start. Then what? We just push backward. Why it happens? When that time our body, full body is at rest positions, but when the drivers just start the buses, if we don't know, then what will happen? The lower portions already is in motions, which is touching with the seat of the bus. The lower portions is one of motions, but upper portions is still due to motion, inertia of rest. Upper portions of our body just continues our rest positions, and that's why it does not want to move on then and there, because due to motion, inertia of rest, it just continues the rest positions and we just push backwards. So these are the common experiment or incident in our daily life. Many are there. So next videos I will explain other examples in our daily life which we face due to the inertia of motion or inertia of rest. Okay, thank you, student.